Okay, this video is also same. This is for the mx Form 5 first chapter progression, and then this is a geometric progressions, and this is about the part 4. I think it's a part 4, but in this video only got one questions, which is the SPM past year question for 2009. Is a question 6. Okay, so okay, I make in this video I only discuss one questions due to two reasons. One is because in last video my video camera started run out of battery, so I have to stop it and record again. And then the second reason is actually I think this is one of the most complicated question in geometric progression. So yeah, it's good to make this question as only one video because I need a lot of explanation in this question. Yeah, I hope after my explanation you can fully understand about this question, because this is one type of very classical question you can find on the most of the reference books. Okay, yes. So first, let's have a look on the question. So he say, Amel dropped a ball from the height of h/cm above the floor. After the first pulse, the ball reached the height of the h1 cm, okay, where h1 is 0.8 of h. So after the second pulse, so the ball reached the height of the h2, where h2 is 0.1 of h1. So the ball continues pulsing until in this way until it stops. So okay, so maybe I just draw out the diagram, make you understand it better. Okay, so okay, let me adjust a bit. Okay, so first you have a flow over here. So, okay, imagine this is a flow. So he say he first dropped the ball. So let's say this is a ball. Okay, so I drop the ball to the floor. So I will the height of the first drop will be h/cm. Okay, I write h. So the first drop will be h. And then the ball, after he touched the floor, actually he will pulse backward. So he will pulse back at the height of 0.8 of h. 0.8 of h. And they call this pulse back height, this height, they call it h1. So the ball will at this height, and then the ball will drop down again, and then he will pulse up. This one they call it h2, and then h2 is equal to 0.8 of h1, means the 0.8 of the previous height. And then the ball will drop again at h2, and then he will pulse up at h3, which is 0.8 of h2. And then continue, drop down, pulse up, drop down, pulse down, until the ball stop. Until the ball stop. Okay, so you must roughly understand the concept. Okay, so of course in this question, it actually tell you the height is 200. It tell you the height is 200. Mean I got the first height is 200. So you have to understand what is the meaning by 0.8 of h. If h is 200, mean 200 multiple 0.8. So here I have to write out the geometric progression. Okay, so I have to write out the geometric progression, because on A, what he asked you to find? He asked you to find the numbers of pulse when the maximum height of the ball from the floor is less than 15 cm. Okay, before I do A, so let me write out the geometric progression. So first height, so the first height is 200 cm. And then the second one actually is 0.8 multiple 200, so you got 160 cm. And then the third one is 0.8. multiple 160. So I just press the calculator, 0.8 multiple 160, so I get 128. And then the fourth one will be 0.8 multiple 128. So I will got 102.4 and dot until the ball stop, meaning the height is 0. Okay, so you roughly got the idea. So that means what? Mean the R from the first term to the second term is 0.8. Then the R means 1.8 multiple 0.8, you get 1.28. And then multiple 0.8 again, you get 102.4. Okay, this is point, not comma, sorry. This is 0.4. Okay, see, this is the geometric progression I will get. Okay, now, okay, because in this question actually he gives you a lot of trap. Okay, so the first, what he asked the numbers of pulse when the maximum height of the ball from the floor is less than 15 cm. So over here, I got the idea is, okay, he wants that the numbers of pulse were less than 15 cm. So he wants to find what's it in the which pulse back the ball were less than 15 cm, because actually you can see that when the ball is pulsed, actually the cm will getting smaller and smaller. Mean in certain term over here he will get less than 15 cm, because you keep on multiple 0.8, the pulse up height will actually is decreasing. Okay, so now you want to find in which term the pulse will less than 15 cm. Okay, but then the first trap a lot of students will make the mistake is, a lot of students will, in order to solve this question, a lot of students will write A is 200. Actually A is not 200, because 200 actually is the ball drop to the floor, is 200 cm, but then this ball haven't pulsed up again. So A, he asked to find the numbers of pulse. What means your A have to start from this one, 160, because 160 is the height if pulse up. So you cannot take 200 as the A, because 200 is just drop the ball to the floor, and then he haven't pulse up, and even he pulse up, he got no chance to reach about 200 height, because in this question he already give you the term is only 0.8 of the previous height. Okay, so the first term over here will be 160. So A will be 160, and then R will be 0.8. Okay, so must be very careful when you see the question, because you want to find the numbers of pulse. Means you have to start from the first pulse. Okay, now you got this information, you just substitute in, then I guess you can get the n. So first is ARn minus 1, so A is 160, R will be 0.8, and then n minus 1 will be smaller than 50. Okay, once again I say this one you cannot multiply in, so 0.8 n minus 1 will smaller than 50 divided by 160. Mean I move the 160 multiple over here, become divide. Then I just press the calculator. Okay, I will get 0.8 n minus 1 will smaller than 0.3125. And then I say this kind of question you have to use log. You have to use log. So I log both sides, so I got log 0.8 power of n minus 1 will smaller than log 0.3125. Okay, then because we learn about log, actually the power we can move in front. Okay, so n minus 1, I put the bracket, will multiple log 0.8 will smaller than log 0.3125. Okay, then the next trap is over here. Because a lot of students, they will straight away move the log 0.8 to this side without change this symbol. Because normally this is a common mistake made by a lot of students, because they just say multiple, move to here is divide. But then if you press the calculator log 0.8, you will get negative value. Okay, so if you press the calculator n minus 1 log 0.8, actually you will get negative 0.0969. We're smaller than, okay, log 0. Okay, I press this one also, log 0.3125. I will get negative 0.5051. Okay, because I say if you multiply or divide negative value, means actually you move this value to this side, actually is called divide some negative value. Or you can say multiple 1 over this negative value. Mean whenever multiple or divide negative value, you have to change this symbol. So I continue over here. So I will got n minus 1. Okay, now I change symbol. Do you see I change symbol? Change, because just now it's smaller, now become bigger than 0.5051 divided by negative 0.0969. Okay, this one must be careful, because a lot of students will make this common mistake. You straight away divide without changing this symbol, then you will got it wrong. Okay, so because I say whenever you multiple or divide negative value, make sure you change this symbol. Okay, and then yeah, you just press the calculator, divide by negative 0.0969. Okay, I will get n minus 1 will bigger than 5.21. Okay, negative 1 move to that side will become plus 1, so n will bigger than 5.21 plus 1, so n will bigger than 6.21, because 5.21 plus 1 is 6.21. Okay, so now you want to find the numbers of powers. So you always take the smallest values of n, because n must be bigger than 6.21. What? So actually you can get 7, 8, 9, 10, 11 until infinity. But then normally we will take the smaller value. So smaller value mean n is equal to 7. Because n must bigger than 6.21. So the closest value, or they say smaller value, or sometimes they will say minimum value, is 7. Therefore I know at T7 the ball will pulse up with less than 15 cm. Okay, this is from my calculation. So he asks you to find the numbers of pulse when the maximum height of the ball from the floor is less than 15 cm. So you can say, start from the 7th of pulse, the ball is actually less than 15 cm. I think this one actually is quite simple. Okay, yes. Then we go to the next one. Okay, then we go to the next one. Okay, I just write some words over here first. The number of pounds is 7. Okay, you just write the numbers of pounds is 7, that's all. Okay, then we go to the second part. Okay, part B. Okay, he asks you to find the total distance traveled by the ball until it stops. Okay. A lot of students have the problem to solve this question. Even this is only 2 marks, but then this one is the hardest part, is about the understanding. Now you have to calculate what is the total distance, because the ball will drop, pulse up, and then drop again, pulse up, and then drop again, pulse up, and then drop again until it stops. So first, you may ask that in which term the height will equal to 0. Okay, if you want to know about this one, you know, in geometric progression, most of the time in order to find about which term, you have to use log. But then one thing over here is, when you press the calculator, log 0 will give you max error. Okay, Log 0 actually will give you max error. Means what? Means actually this is infinity. This is infinity. Because the values of the ball pulse will getting smaller until can be very small, can be 0.1, 0.001, 0.00001, can be very small until infinity. So you must know in this question you have to use the formula of sum of infinity, or they call it sum to infinity. Okay, but then in the question he didn't mention you have to use this formula. So the first clue over here is you have to know in this question you have to use sums to infinity. Okay, so in order to calculate this question, so let me brief you about the total distance traveled. So the first is, do you see actually the distance traveled like this one is 200 and 160 plus 160, and then you have to plus 160 again because the ball actually will drop down, and then you have to plus 128, and then he will drop down at 128 also. So you cannot straight away solve this question from the geometric progression over here, because you might say straight away use sum of infinity, then you can get the answer. No, you won't get the answer in that way, because actually this one is repeat. You got 160 and then you got drop down is 160 also, and then here pulse up is 128, he will drop down at 128 also. This is a distance travel what? Then he will pulse at 102 and then he will drop down at 102. So actually we know actually from 160 start, actually the distance is double. So in order to solve this question, you must have the very clear mindset is, okay, so let me calculate the total distance traveled from this diagram. Okay, so the first he dropped down only. So he dropped down, he never pulse up. So it's 200 cm. Okay, and then I say from 160 start, actually the distance will double what? So okay, so from here actually you can get the distance actually smaller until infinity what? So from here start, we will say this is sum of infinity. But then because it pulsed up and dropped down, so actually we got 2 of sum of infinity. Okay, 2 over here is stand for one is he pulsed, another one is because he dropped. So it's double of sum of infinity. But then why can't we start from the 200? Because 200 only drop, do not pulse up what? Because he do not pulse up at 200 height. So 200 we have to do it separately. Okay, I hope you can understand. Okay, so in the sum of infinity, the formula is A over 1 minus R. So in order to use this formula, I say R must smaller than 1. So here R is 0.8, so it's smaller than 1. Okay, first condition fulfilled. And then the A over here is not 200, must be careful. The A over here, because this is the pulse up and drop down, pulse up and drop down. So the A over here should start at 160. Because start from 160 only, he pulse and drop what? So A over here is 160. Okay, so this is the total distance traveled. Will equal to this one. Okay, so I just solve this one. 200 plus 2 multiple. Formula is A is 160 divided by 1 minus R, 1 minus 0.8. Then we equal to 200 plus 2. Okay, this one use calculator. And then we got 160 divided by 0.2. So it's 800. And then this one will be 1600 plus 200 is 1800 cm. So this is the total travel distance. So yeah, so about this question you must fully understand the question in order to solve lah. because the trick here is actually first when he dropped the ball at 200 cm, the ball never pulsed at 200 cm, he pulsed at 160 and then he will drop at 160. So the last part is like this until he stopped. So because until it stopped, a lot of students trying to find in which term the ball will stop, but then it's very hard to find. So because the value will become smaller until very small. So the best way to solve is we use the sum to infinity. Okay, and then why I need to double up the sum of infinity, because start from 160 actually he will pulse and drop at the same distance one. So means first sum of infinity is for all pulse up one, and then the second sum of infinity is for all drop one. So yeah, so must be very careful about this question. Yeah, so I hope this video can make you better understand about geometric progression, or even make you start to love about this chapter. Okay, thanks for watching.